Welcome back to Uncle Fish. Today we're going to talk about operators in C++. And if you've been following along with us and learning, you've already seen some examples of these, but today we're going to categorize them and talk about some of the more advanced ones. Let's start with one of the more basic ones, which is the arithmetic operators. And this is pretty self-explanatory, right? So anything where we are doing some arithmetic operation, so addition, that's the plus sign, minus for subtraction, star for multiplication, division, forward slash, and then the percent for the modulo or the remainder operator. And again, like I said, if you've followed along so far with us, you've likely seen these already in a bunch of different examples that we've done. Another set of operators are the operators of assignment. Okay, and the most basic example obviously is the equal. And essentially what we're doing is we are assigning something. So we'll say int a equals 17. And basically what that means is that the number 17 is what we are assigning, hence the word assignment, using the equal sign to this particular variable. There's a subcategory of this called compound operators. And basically what that is that we combine the equal and then one of these arithmetic operations to almost create like a shorthand. So D, here's an example. So D plus equal 6, right? Really what this is saying is D is equal to D plus 6, right? So it's just shorthand and it's combining or compounding, right, the two operators together. But this is essentially what you're telling the language. And you can replace this plus sign with any one of these, and it would have the same effect. All right? Another group of operators kind of along the same lines are increment and decrement operators. Okay? These operators essentially are incrementing by 1 or decrementing by 1. So if you had a variable, for example, x, and you said x plus plus, what you're really saying is x is equal to x plus 1. Okay? There's a decrement operator, very similar, and this is saying x is equal to x minus 1. And you'll see where this comes in handy, especially when you're doing loops and you want to, increment by 1 or decrement by 1 or what have you. It's this nice shorthand to help you out. This is happening post, right? So it's happening after the variable. So x and then plus plus. So these are called post increment. This is post decrement. The other category here is pre, and you can say plus plus x. Oh, that's there you go. Or minus minus x. So notice it's coming before the x variable. There's absolutely a nuance here, and we'll show you in the code. And the nuance will happen when you're assigning this to a different variable of when exactly the increment is happening and when exactly the assignment is happening. But we'll go over that in code. So just keep that in mind from that the order here matters. Okay. Another set of operators are the relational operators. And relational are pretty simple, but this is essentially, if you think about it, is one thing that you want to compare to another thing, and you want to see how they relate to each other. Are they, for example, equal to each other? That's the equal operator, okay? Are they greater than or equal to them? Are they less than or equal to them? And the result of all of these things is typically either true or false, right? Some Boolean value. But you get the idea, right? So we're trying to see how two things relate to each other. And there's other examples of this, like not equal to, for example. And you'll see there's different variations of doing these things as well. Like, for example, I've seen less than equal to also meaning not equal, okay? But you get the idea that that's what we're talking about here, is this is how two things relate to each other. The next set of operators are a little bit more complicated. So what we're going to do for that is we are going to clean up some real estate here and then shift over to some of the more complicated ones, okay? And again, at the end of this, we will go over some code. We'll show these things in action, and then hopefully that will drive the point home and make this all easy to understand. So another category of operator is logical operators. So there'll be times when you want to perform some things on Boolean, And maybe you want to do or see what the output of something would be for more than one thing to be true or false. Okay, and that's where you'll use logical operators. So let's give an example. So and is a logical operator, and in the code itself, it's ampersand, ampersand. And what does this really mean? So let's go look at that. Let's assume for simplicity's sake that we have two operands. Operand 1, operand 2. Forgive me for my having the S there. And then an output. What are we going to get at the end of this? All right. So if the result of operand 1 is true, and remember, we want and is meaning that you want both things to be true for the output to be true. So if operand 1 resolved to true and operand 2 resolved to true, then the output would be true. If operand 1 resolved to true and the second operand was false, well, remember, we need both of these to be true. So the result would be false because both of these are not true. Similar, of course, if you flip the order, you would get false. And then, of course, if you had false and false, you would also end up with false because none of them are true. Okay? And you'll see how this, like when we talk about what operands are, these could be different comparison operators, other types of things that you're doing that are going to result to a Boolean value. But now you can combine them, you can join them and say, hey, both of these have to be true for the output to be true. And that's what the AND operator is doing. There's an OR operator with as depicted in the code as pipes, two pipes. And what this is essentially saying is they don't both have to be true like AND, but one of them has to be true. So if you look at the same table, right, true and true, if operand A is true and one is true and operand 2 is true, the result is going to be true because one of these is true, right? You can see both of them are true in this case, but one of them is true, and that's the key for OR. In this case, true and false would also resolve to true as an output because, again, one of them is true. This one is true. Okay? If you flip it, it's the same thing. One of these is in fact true, so that's true. And then if you say false and false, well, none of them are true, so that still remains as false. All right? And there is a not operator. This is typically an exclamation point, but it's basically, think of not as the opposite, okay, of what you're passing in. So if you say, like, for example, not of true, that would be false, and vice versa. And you'll see that this not can be used in variables and other types of things, but basically you're checking for something and the opposite of it, essentially. All right? So this is these things are typically called truth tables. I kept it simple here with operand 1 and 2, but again, you can have multiple operands. But this is the whole point and idea of logical operators. All right? Another category here that's a little bit more on the complicated side. Let's erase this. And show that. Erasing here for some reason is very therapeutic for me, at least. I don't know if it is for the viewers. Is the operator called a ternary or conditional operator. Right? So this one's a bit confusing, but if you bear with me, I think we can make sense of it, okay? So a really simple example is let's take a line of code and try to answer what exactly it's doing. So int, the variable v, I'm going to say is equal to some comparison operator that I'm going to do here. And the question mark, then 10 colon 20. And trust me, I get it. This looks really cryptic. Who's going to tell what this means? But as we break it down, it'll make sense. And it'll focus in on the fact that we're checking on some kind of condition to be true and taking some action. So what's our condition, right? We mentioned it here. So we have this condition that we want to go check. And if this condition results to true, then we want to go to this. And if this condition resolves to false, then we want to go to this. But when I say go to this, what are we really talking about? What we're really talking about is, remember, this is a assignment operator. So I want v to equal to true, or I'm sorry, to 10 when this is true. I want v to equal to 20 when this is false. Okay? So if you look at this example, is 5 greater than 3? 5 is greater than 3, so that means that this condition resolves to true. And so in this case, in this code, v would in fact equal to 10. Okay? But if I, for example, took this and said, is 5 less than 3, or is 5 equal to 3? right? This would be different because now it's not exact. It's not equal to 3. It's not less than 3, and so therefore it would resolve to false. And in that example, v would equal to 20. Okay, so that's another example of an operator. And then lastly, there is a category of operators called bitwise operators. And we'll talk about this, but this is more for a separate video as it's a little bit complicated. But this is really about similar operations that we've already gone over, but how they pertain to binary, for example. Okay? And there are bitwise AND operations, there are bitwise XOR operations, and so on and so forth. But again, I'll save that for another video as it is a little bit more complicated. But I just wanted to be complete here on the different kinds of operators. All right. Now, with that said, like we've done in previous videos, we will shift gears to actually looking at some code. We'll walk through that code to kind of illustrate and drive these some of these principles home. All right. So here we go down that same line. Now, in just like other videos, we recommend that at this point you want to pause the video, look at the code on the left here, right? See if we can make sense of this particular code and kind of follow along and test yourself on like, what do you think the output would be as you go through the different lines, okay? So we will, of course, assume that you paused it already and then execute the code, and let's go see together what's going on here, all right? So let's execute it, operators, and let's walk through it. I'll kind of breeze through the first set because, again, this is pretty straightforward. Like these are the arithmetic operators. In this line, we're printing it out. We're saying set the variable a equal to 10. We're printing that out, and then we're setting the variable b to 5 and printing that out, right? And then we're going to do some arithmetic operations. So a plus b, we'll set that to sum, and then we'll print out the sum. Well, what's a plus b, right? So 5 plus 10 is 15, so that's correct. 10 minus 5, if you're looking on this side of the screen now, 10 minus 5 is 5. 10 times 5 is 50. 10 divided by 5 is 2. And then 10 modulus 5, meaning if you divided 10 by 5, what would your remainder be? It would be 0. Okay? And now from the assignment perspective, again, we were talking about the most basic one, right, which is equal. So yes, I'm setting the variable c. I'm assigning it the value 20. And then we're going to show some compound ones here. So remember, c star equal 5 is the equivalent of saying c is equal to c times 5, and so on and so forth. Okay, so follow along. We do a bunch of different operations in here, and then at the end, you get this final c value. So follow along and see if it is in fact matching what you would think it is. Now down here, we're going to shift over to the relational operators. And so again, remember, what was the relation? Relation was to say I have 2 or 3 or whatever values. I want to see how they relate to each other, and the result should be a Boolean value, okay, or a Boolean result. So here, remember, we still have the same a value and b value. A was set to 10, b was set to 5. So we're going to check this variable is greater. So here is our relational operator. Is a greater than b? Okay, so is 10 greater than 5? 10 is greater than 5. So we'll print that out. So what happens on our code here? We will see that so remember, this was 10 and 5. Is a greater than b? Yes, it is. But notice we got a result of 1, and not what we might have expected, which would be true. But without setting the right manipulators, you're not going to see true or false. You'll see 0 for false and 1 for true. And we can show, and we did show in previous videos as well, but that you can manipulate that, right, with this particular manipulator called bool alpha, basically saying, show me the Boolean result in alpha numeric as opposed to just, the 0 and the 1, but in characters, basically. Okay, so once we set that, then you can see is a less than 5? So is a less than b? Like 10 less than 5? 10 is not less than 5. So now it'll say false instead of 0. Is 10 equal to 5? That's false. That's not true. Is 10 not equal to 5? That is true. So you'll see I'm in this line here. Is a greater than or equal to b? So we're showing different examples of the greater than and less than. Okay, so hopefully all of those make sense. It's pretty straightforward, right, for these particular relational operators. The logical operators, this is where we were doing those truth tables, basically, right? So we wanted the and the or, and also the not. So let's give those examples. So I have a Boolean condition of true. I'm going to set that to condition 1 is true. Condition true is false, okay? So remember, these are the two operands, as we were talking about before. So the and result of this, I'm going to store in a variable called and result, is condition 1 ampersand ampersand condition 2. So I want an and percent, right? So the result should be that this is true and this is false. True and false means they're both not true. So the result should be false, right? And you should see that here as well in our logical operator. So the and result was in fact false. The or result is true because one of the conditions is true. Condition 1 was true. So that would be the or result. And then here's a not result. So the not result, I'm going to take condition 1 and do the exclamation point in front of it, right? So bang, condition 1 true, the result should be false, and it's false. All right. This part of the code is a little tricky, so just try to pay close attention here. This is the one we were talking about from the increment and decrement perspective. So we're going to set a variable x to 10, okay? And then we're going to set another variable, my result, to x plus plus. So this is the post increment example. So follow along what happens here in the code. X was set to 10. We did the post increment, so x plus plus. And remember, that was x is equal to x plus 1. So that is 11. So x is after the post increment equal to 11. But what did the variable that we assigned it to, my result, become? Notice something really strange happens. My result after the post increment is 10. It's not 11, right? And the reason is because we are doing the increment after the assignment, okay? And so now let's see the opposite. So the opposite is I'm going to set x back to 10, right? So this is in the code here. X is back set to 10. But now I want to show how the pre-increment works. So in this case, I'm going to say my result 2, this other variable, is going to increment it pre. So plus plus then x. So notice what happens in this particular case. So x is set to 10 again. The x value for pre-increment, that's still 11, meaning x is still 11. But my result 2 is now also 11 because I incremented it first and then assigned it to my result. Okay, so these little nuances are really, really important, and I've seen countless bugs in students' code that don't pay attention to when, in fact, you're doing this, and there'll be cases when you want one over the other. And then the last thing we're going to talk about is the conditional one that we went over, the ternary one. So here we have end result equal to some condition being true or false. The question mark is kind of like an if. So if this is true, then I want 100. If this is false, then I want 200, meaning I want the result to be equal to 200. So what was condition 1? Well, condition 1, way up here, we said was true, and so therefore the result should be the first one, which is 100. All right? Hope all that makes sense. Thanks so much.